Hello, so this is a Teleton stereo amplifier. I don't know, it has multiple names. I've seen ones online where that is a different brand there. And it's got an issue where, take the top off, I've been working on it for quite a while. It's got an issue where this channel works fine, but this one, the right channel, doesn't. You don't get any sound out of it. That was the original fault with it. I've been working on it for a few years, just slowly gaining more knowledge about it as I've been going. What I've had to do so far is I've replaced these variable resistors. I've replaced those three. That one's an original one. And then what I've done is, you can see here where this resistor is a different colour, and you can sort of see underneath the board it's got like a hole in it. This resistor kept blowing up. The transistor which was in here was, and we'll get to that later on in the video, all of that, but that transistor was broken and it was causing it to blow up, and I discovered that by using a multimeter, which we're also going to get onto a little bit from what I do have recorded, but a lot of the first bits I don't have any footage of, so that's why I'm explaining it now, and then we'll get on to the bit I've been doing most recently. On the top you can see a big burn mark. That was likely from that resistor. Yeah, so I've done quite a lot of work to this so far and it still don't work, but it's been quite interesting. Okay, this transistor has the same input as the working side, about 100 ohms and 9 kilo ohms, but on the output it has not even 1 mega ohm, whereas the working side has 13 mega ohms. So I think I'm going to remove this and see what happens. I've been doing some more measuring and I think the short is actually before this component I took off, which is odd because it was burnt. So we have these transistors here, one here, and then we have the same one on the other side. And going, I think it's this one. Yeah, going into it, we have a smaller ohms thing than the one on the other side. This one has 13 ohms, mega ohms going in, whereas this one only has 3 mega ohms. So then obviously its output, which I think is this one, is smaller. Yeah, of only 200 ohms, whereas the other side of the board we get an output of 6 kilo ohms. I think I need to explain a little bit more about what I was doing there. Oh. I've just noticed something as well. That's actually right. That might be why it's not working currently as well. Because I was just watching the other videos and I realised that I took this out while I was trying to fix it, but I just looked at it, I haven't actually put it back. That might be why it still doesn't work. Oh my gosh. This resistor here, and so I think that's what I was looking at. I was looking at around this area. And along here, and there's like it all connects in a way. I can't quite remember how I was doing it, but it like all connects. And there was this one, and there's like the main line which connected everything, and it went all the way up to this transistor here, which was broken. On this side, we had such a low resistance compared to this side along that line, and it connected to this resistor which kept blowing up, and so I followed the line and I ended up getting to this one, and I checked it, and then I compared its readings to these ones here. So the transistor which was here, which is this one, the readings, I think it was all just shorted or something. I can't quite remember now, and I don't have the multimeter with me anymore. And so once I removed this resistor stopped blowing up here. So basically what was happening is every time I turn it on, that would start smoking. Once I removed this, it stopped. It worked. Well, the channel didn't work, but it didn't blow up anymore. So that's where we are now. So next we need to go and purchase one of these and try and put it in and see what happens. That's where we are currently. I have a schematic here, which is what I was comparing it to as well. So like I was trying to, like, I can't remember if I used this one or the component diagram. I found this resistor on here. I can't remember which one it was anymore, and then from that I remember being really confused because it was like, because it's connected to ground on one side and then on the other side it's not. And so I was trying to figure out why why it was on the other side it was such a low resistance. So why the line which was here going through, which connects to this one, was so low resistance. The resistor's here, and that goes to this, and you can see it goes onto there, and if you follow that, it goes straight up into that transistor there. Oh, it don't come out the other side. Oh no, it is. Oh my gosh. Is it gonna blow up? I'm really worried it's gonna blow up. It's kind of working. I guess that proves that the transistor was broken though. These just arrived. Some replacement transistors. I'm hoping they're the right ones. It says D313V, whereas the ones on previous ones don't say the V. So this one's the original one, which is broken, and that's the new one. And as you can see, it doesn't say V on the original, and I believe that code is just like a manufacturing code, although now this is according to AI though. The first letter is like it's gain, how much gain, and well, they both say D, so hopefully they should work. Let's try it. I popped the little red thing on the center pin there. I'm going to pop this in. Right, there we go. And it looks like it lines up with the hole there. I guess next is to solder it in. Pins come through on the bottom. Yeah. Shit. There's an issue. That's the trace sticking up there. So the trace has come off, which is not good at all. So I'm gonna have to try and solder that back down or push it down because it hasn't fully come off, it's just peeled up a bit. Right, there we go. I've somehow managed to put the trace back down. Like, it hadn't fully detached, there was still like a little circle which I pushed back through the pin, and then I soldered it down. Everything connected up, it's plugged in. I've got iPod plugged in here. Is it playing? iPhone ran out of storage. It's on. It don't work. After all that, and all that money I just spent on it as well, it doesn't actually work. Oh my gosh, oh my gosh, oh my gosh, oh my gosh, I'm a fucking idiot. I took the fuse out. I haven't put a fuse in it. Now I have a fuse in it. Let's turn it on. let's plug it in first, that might help. It doesn't work, does it? Oh. Damn it. I really thought that was going to be it. I really thought that was going to fix it. So, I've only got the speaker plugged into the channel, which is broken. I'll turn it on. It makes a loud buzzing sound. Turn it off. On. Then it gets louder. So, and the other channel doesn't do that. I have now put the new one here. See whether that's the issue or not. So I'm gonna. It works. Oh shit! I might have just blown up the transistor I just got. Okay, so I screwed it down. I had to resolder it a bit because it was too high up. Oh. And I put a new fuse in it. But it is no longer new. I just spent ages putting that one into there because the traces were all torn. I don't believe these have directions, so I'm just gonna put it in from the back here. You can see I'm just gonna solder that. There we go. That's soldered on now. It might actually work now when I turn it on. Oh. Whoops. Tidied that mess up. Got a fuse in it. We've got our new transistor in there instead, because it is now. We've got that put in. We've got my new resistor. We've got new variable resistors. I'm gonna plug it all in and see if it works. It's making static sound. Oh, Jesus Christ. Okay, it still doesn't work. Oh my gosh. It definitely still doesn't work. Oh my gosh, it's really loud. So that popping is coming out of the broken channel, and any good sounding music you're hearing is coming out the working channel, which does have the new transistor in it, so the transistor's good. But it means even though I've now put that back in, there's still something wrong in this circuit. Damn it, I really thought I'd fixed it when I've realised I hadn't put that in. Okay, so now this is basically where we are currently. I've got, I've put the new transistor into the left channel, and it works perfectly fine. This channel works great. I took the transistor I took from the working channel and put it in replacement of the broken one, and it still doesn't work. So it's no longer an issue with the transistor. It's something else. As we saw, that didn't fix it with putting that in. To finish, I'm going to talk a little bit about what I've learned about how these transistors sort of work. Maybe in the future, when I find something else, I'll post an update. Okay, so thanks so much for watching. This has been quite a journey trying to fix this, and it still doesn't work, which is a shame. I have no idea what I'm doing about anything I've been doing in this video. I've just been learning as I go along and hope for the best. So these two are broken, and these two are from a different amplifier, and we saw it kind of worked with one of these, so I thought maybe if I got that one, it would fix it. An NPN transistor, or you've got a PNP transistor. NPN negative, positive, negative, and then one of these is yeah, this one is an positive, negative, positive. For a class B or class AB amplifier, what they do is they have two transistors, one which is NPN and one which is PNP, which was what this amplifier took these two out of had. And one will do 180 degrees of the signal, another will do the other 180 degrees of the signal. But on the amplifier I've got, it only had NPN transistors. It has negative, positive, negative transistors, but it doesn't have any positive, negative, positive, and PNP. And I was apparently, because I was really confused, apparently it's because in older amplifiers like that one, they would do they would only use NPN transistors because they were easier to make and more reliable at the time compared to the PNP transistors. So that's why my amplifier only had NPN transistors. All the different things do within the transistor. So that's a transistor. You've got the base, I don't know how you say that. And you've got, this is the output of the transistor. The input of your signal goes here. Got positive, got ground, we've got some resistors here and here. These all sort of like control gain. Capacitor here, which filters out any DC noise from your signal. You have something called the Q point. My understanding of it is your transistor, so it won't actually be on unless you have a signal which goes above the active point, and like if you set the Q point low enough, then the transistor will only be on when it gets a signal, so it will only be on for its half of the wave. But then in a class A amplifier, this is my understanding, I could be wrong, if you set the Q point in the middle of the transistor, it can do both waves, because a class A amplifier, it's always conducting, it's doing 360 degrees of the signal. But the reason we do it with two separate transistors in a class B amplifier is because it's more power efficient, as they're not the transistors not always conducting. Thanks for watching.